Hello, my fellow chemists. In this video, we're going to take a look at calculations with significant figures, and in particularly, we're going to take a look at addition and subtraction with significant figures. This video is labeled as intermediate because it is assuming that you already understand what significant figures are and can also look at a number and determine how many significant figures are in that number. If you need a review on any of those topics, I'll put a video in the upper right-hand corner. So let's begin looking at addition and subtraction with significant figures. So the main rule that we need to follow is up here. It says, go through the calculation and make note of the smallest number of significant figures after the decimal point of the set of numbers used. So let's go through. I have 4 examples on the screen here. Let's go through these 4 examples, applying that rule, and let's determine how many significant figures should be in the answer. So for our first example up here, we have 4.09 minus 1.008. The 4.09 has 2 digits after the decimal, and the 1.008 has 3 digits after the decimal. Our answer, therefore, can have a maximum of 2 digits after the decimal. So your answer is going to have the fewest digits after the decimal as whatever numbers that you're starting to work with. So if we take a look, 4.09 minus 1.008, you'd initially get 3.082 as your answer, but then when you round it to the correct number of significant figures, you could only have 2 figures after the decimal place, so your answer would be 3.08. The 2 is less than 5, so it doesn't cause the 8 to become a larger number. The 8 just stays an 8. So our total answer has 3 significant figures in it. And if we wanted to write this in scientific notation, it would be 3.08 times 10 to the 0. And again, all 3 of the numbers out in front of the multiplier are significant, and our number out in front of the multiplier is between the size of 1 and 10. So for the first question, the correct answer with the correct number of significant figures would be 3.08. If we take a look at the second problem, 82.61 plus 1.2 plus 14.396. The first number has 2 figures after the decimal. The second number has 1, and the third number has 3. That means our answer can have no more than 1 decimal place because of the 1.2 that only has 1 decimal place. So when you would add those numbers together, you would initially get 98.266, but then when rounded for the correct number of significant figures, your answer would be 98 and we can only have 1 decimal, so it would be 3. The 2 would get rounded up to a 3 because the number after it, 6, is 5 or higher. So that would cause the 2 to get rounded up to a 3. And then this is a total of 3 significant figures for this answer. And if we were to write that in scientific notation, it would be 9.83 times 10 to the 1. And that's the answer for the second problem, 98.3. For the third problem, we have 439.19 minus 1.28. Well, our 439.19 has 2 digits after the decimal, and our 1.28 has 2 digits after the decimal. So that means whatever answer we get is going to have 2 digits after the decimal. So if you take 439.19 minus 1.28, you get 437.91. And that's already 2 digits after the decimal, so we don't need to round it to remove any of the digits. So our answer is going to have 5 significant figures. And if we were to write this in scientific notation, it would be 4.3791 times 10 to the 2. So that's the correct answer for our third problem. And our fourth and last problem, has 212 minus 19.36. Well, the 19.36 has 2 digits after the decimal point, but our 212 has none. No digits after the decimal. So that means our answer cannot have any digits after the decimal point as well. So if you take 212 plus 19.36, you end up with 231.36. But remember, we can't have any numbers after the decimal because our 212 doesn't have any numbers after the decimal. So when we round this for the correct number of significant figures, we're going to have 231. Realize that this 3 is less than a 5, so that means the 1 is going to stay as it is. It's not going to round up to a 2 because this digit after the 1 is less than a 5. So if we were to write this 231 in scientific notation, it would be 2.31 times 10 to the 2. And again, the number out in front of the multiplier is between the size of 1 and 10. So that's why we put the decimal point where it's at, and we have 3 significant figures there, and in our answer we have 3 significant figures as well. So that would be the answer to the fourth problem. In our next video, we're going to take a look at calculations with significant figures when you're doing multiplication and division. That's it for this video. I hope you learned something. If you did, make sure you subscribe and like, and I'll see you in the next lesson.